In this video, we're going to look at how to interpret an inequality using a graph on my calculator. As always, I'm using a TI-84 plus CE, but this one will be pretty similar even if you've got a different calculator. And I've got a problem to start out with. I'm going to use an absolute value because students struggle with absolute value. Now, anytime you use a calculator, I generally recommend doing two lines. So I'm going to have the left-hand side be one line and the right-hand side be the other line. I use this for equal problems as well. So let's go to y equals. Now again, to get that absolute value, I've got to go to the math menu, the good old math menu over here, and I am then going to have to go right to the num sub menu over here, and it is that very first option, ABS. I have another video about typing in those absolute value problems if you're having problems. So let's type in x plus 4, and then my second line is just y equals 2. So let's go ahead and get the graph. Now again, I like to have it as two lines so that I can really compare the left-hand side as one entity to the right-hand side of another entity. And first things first, I can use this to at least say approximately where those two intersection points will occur. It looks like one of them is going to be at approximately -2, and it looks like the other one is going to be approximately -6. Now again, I always start with an easy problem, so I do have nice numbers. We'll see in a moment what to do if our numbers are less than nice. So I'm going to start by looking at the table. So I'm going to hit second graph to pull up the table. And how do I know, using a table, if two graphs are intersecting? What I'm looking for here is the same y values. So as I go down, it doesn't actually matter what those y values are, although obviously the right-hand side is nothing but 2. What matters is that they are the same y values. So if we look, when x is -6, I've got the same y value. And then let's scroll down. At x is -2, similarly, they again have the same y value. That is what I thought using the graph, and that would be how I would interpret that using the table. I do have another video about finding the intersections. I'm going to do that very briefly here. Please consult that video if you want to see it in more detail. But I'm going to hit second trace for the calc menu, and because I'm looking for where they cross or intersect, I'm going to pick option 5. Now again, you have to do this one at a time. So let's start with the leftmost one, and I have to pick the first curve. Let's pick y1. The second curve is y2. Let's pick that. And then I have to guess. Because there are two of them, I have to do them one at a time. Again, I said I was going to do the left one, so let's take that cursor somewhere vaguely close. Again, it does not have to be exact, so long as I'm reasonably close, that's good enough. And then let's hit enter. And it does give me -6 that way as well. And that will work if your values are not so nice and therefore not showing up with your table. So I've found where the two graphs are equal, but here I'm trying to solve it as an inequality. Now I'm going to repeat this graph up here just so I can highlight a few things. So I've got my one line here, and here's my other line. We've already determined that's -6, and that's -2. So here we want to know where it's less than. So I am now looking at the y's and basically asking, where is this blue, the absolute value graph, lower down than that straight line red graph? Well, it's lower than it right here. I'm going to go ahead and shade it in there. So where is it less than 2 would be from -6 to -2. And here I am going to put parentheses around that interval because, of course, we are strictly less than. What if I've got the exact same problem, but now I'm looking for where it's greater than 2? I've got that same picture, and let's use a red line this time just so I don't have to redraw it. So here where it's greater than, well, it's going to be greater than it over here on the left-hand side. And similarly, it's going to be greater than it over here on the right-hand side. So for that one, I'm going to be going from -infinity to -6, since that arrow is going left. And then I'm going to go from -2 to +infinity, since that arrow is moving to the right. Sometimes we put that little U in between, sometimes we put the or, sometimes we don't worry too much. Consult your instructor about how picky they want to be about what we're going to put in the middle there. But either way, we are hopefully able to see those two intervals by using the graph. So again, the graph does not tell me directly which part is less than and which part is greater than it. I have to look at that picture and then know, do I want the part underneath for less than? Do I want the part above for greater than? So again, I have to interpret that graph. The calculator will not tell it to me directly. Let's just see how we would look at this with another one. Let's do a quadratic. Let's do x squared minus x minus 6, and let's do greater than 0. So let's go to y equals and type that in. So I've got x squared minus x minus 6. Again, those are subtractions, so I'm using the subtraction sign. Now, because the other side is 0, I'm not going to bother to draw a line that is the x-axis. So putting in an extra line there isn't really necessary, so I am just going to do that left-hand side. And so let's go ahead and hit graph. So I can see my graph there, and once again, I can use a combination of the graph, the table, and that calc value to find those two intersections. And again, I've picked one here that does work out nicely, just to help me see that better. So that left one is going to be -2, and the right one is going to be +3. Now again, less than 0, here I'm comparing just to the x-axis. So with less than 0, it's going to be this middle interval from -2 to 3. And again, I've got parentheses there since I am doing strictly less than. If instead I want x squared minus x minus 6 to be, well, I'm sorry, I did do the less than one there. Let me change that. Let's go ahead then and do greater than over here. So greater than, let me do this in green or in red. That's going to be this left-hand side and then this right-hand side. And so that's going to be -infinity to -2, and then +3 to +infinity. One thing I always tell my students, between these two, I should be getting everything, because pretty much the entire graph is either less than 0 or greater than 0. I'm not worried about those 2 points exactly at the moment. So there definitely shouldn't be any overlap. These two should be different. And between the two, I should have covered everything. Unless, of course, my graph does not have a domain of all real numbers. That is not the case for this particular function. So again, I am expecting to cover everything. And you can also make number lines if you're having a little bit of trouble. I sometimes will draw out those number lines, and again, use that graph to help me out a little bit. So we would say from -2 to 3, well, that is great, or that one was less than 0. Over 2, that was greater than, and 3, that was greater than, to kind of help me see which interval goes where. But there is at least one way to use the graph to help to see that.